Assalamualaikum warahmatullahi wabarakatuh. Semangat pagi Sobat MIPA. Pergi ke pasar membeli mangga manis dari Kediri. Selamat datang tamu berharga, Profesor Gana hadir di sini. Semoga Sobat MIPA selalu dalam keadaan sehat dan penuh semangat. Selamat datang di Mikrofon, MIPA Riset, obrolan fun dan inspirasi. Hari ini adalah episode yang sangat spesial dan bersejarah untuk FMIPA UNESA. Di tengah rangkaian acara Visiting Top Professor VTP 2026 yang berlangsung dari tanggal 18 sampai 22 Mei ini, kita kedatangan langsung sang bintang utama di studio Mikrofon. He is a world-class mathematician, Professor of Mathematics at the Akenten Appiah-Menka University of Skill Training and Entrepreneurial Development AAMUSTED, Ghana. Please welcome Prof. Ebenezer Bonyah, Ph.D. Hello Prof. Ebenezer, welcome to our podcast. How are you doing today and how do you feel about your visit to UNESA so far?
Thank you. I feel very good. Today, I'm happy to be in UNESA this time.
Oke, alhamdulillah. Beliau merasa sangat senang dengan sambutan hangat ya di UNESA gitu ya. So you can feel so good and feel warm here. Oke. Baik Sobat MIPA, kita langsung masuk ke perbincangan inti mengenai tema besar VTP tahun ini. So, Prof. Ebenezer, your main theme here is bridging science and education through mathematical modeling for sustainable development. Could you break this down for our audience? How can mathematics, which my student often thinks is just about abstract numbers, actually play a crucial role in achieving sustainable development goals?
Thank you. It is believed that creation by Allah is orderly, which is mathematics. It is also believed that STEM, which is science, technology, engineering, mathematics, the lubricant or the fulcrum is also mathematics. And therefore, any discipline that someone engages or studies to bring different discipline as a unified to get what you call interdiscipline, you require something to blend. That blend is mathematics. And therefore, sustainability means the thing can be contained in a longer period of time. So for example, you talk about epidemiology, let's say COVID or dengue fever, then you require an expert in health science, let's say health practitioner or a medical officer or a biologist. Then that is not enough. You also require a mathematician who will combine information given by a health officer into a mathematical algorithm. Then this mathematical algorithm will now use to create a model. Even creating the model, depending on what you want to do, you may even require a data scientist to help you to analyze this model in a bigger platform or a data-driven system. Then you need to interpret. So the interpretation will maybe require an intervention or change of life or the way we do things. That is sustainability. And therefore, modeling occasions or influences sustainability as human enterprise.
Okay, so you should know about the mathematics first, the root of mathematics, and then
very well,
right? And then you can blend it with many of subjects such as academics or biology or physics or anything. So we can combine and make models from variable, so we can make predict to the future, right?
Very well.
Yeah.
So model will help you to predict. So that prediction can help us to do our sustainability. What if he says that in the next 5 or 2 weeks there likely to be an epidemic here? Then we have to bring in sustainability. How do we now sustain our system? Do we close the university? No. Maybe the thinking may be going virtual so that we can sustain the university to run. That's a sustainability.
Oh, oke. So jadi teman-teman, dari bagaimana matematika itu kita melihat ya bahwasanya kalau matematika itu bukan hanya sekedar instrumen nyata gitu ya untuk di atas kertas aja, tapi benar-benar kita bisa implementasi ini, kita bisa menggunakan dari berbagai sudut pandang gitu ya, lalu kita buatkan seperti variabel-variabelnya, lalu kita juga lihat bagaimana mereka berinteraksi satu sama lain, sehingga kita bisa memprediksi ke masa depan tuh kira-kira seperti apa sih untuk menjaga si sustainable development goals-nya ini, seperti itu. Oke.
Yeah, let me also add this. You take modeling like, if you look at the skeleton of human body,
Ya.
which could be lifeless, there's no life. So take modeling like the one giving life to the skeleton. So maybe you link modeling in the context of the human system. If the nervous system, the nerves are not working, even though you have leg, you cannot move. So in this context, the modeling, the mathematical modeling is being contextual like a nerves, which give strength for the movement. So mathematics is a dry subject, all right. If you say 2 plus 2, there's nothing that I can touch, I can feel. But I can model 2 plus 2 to give flesh into it, to make real life meaning, and even use to predict. So that is what we are talking about.
Oh, okay. So like the mathematics is also like you like make like a stone, like a bone, and then like a saraf gitu ya. So like jadi teman-teman kayak matematika itu tuh bisa dianalogikan gitu ya seperti tulang kita dan juga saraf-sarafnya. Jadi kayak matematika itu tuh kayak tulangnya. Nah, tapi variabel-variabelnya itu tuh bisa teman-teman masukin gitu loh. Jadi kayak sarafnya jadi yang ngegerakin badan kita. Ingin badan kita tuh arahnya kemana, seperti itu. Oke, Prof, now let's talk about your heavy schedule here. From May 18 to 22nd, you are conducting general lectures, workshop on scientific writing, and even collaboration initiations. From all these key activations, what is your main target or expectation for the student and lecturer at FMIPA UNESA?
Thank you. My expectation are these. One, I expect that different department apart from mathematics, education, or the other aspect of maths will now inculcate modeling as a principle of teaching. Biology can use modeling principle as a pedagogy in teaching what they teach. I know that the faces also look a bit abstract in some context. They can use modeling principle as a pedagogy for putting real life in physics, in chemistry, and so on and so forth, and other discipline. Then, when it comes to students, my expectation is that students should be engaged now based on modeling principle, and that will arise their interest in learning the subject they study, be it math, be it physics, be it chemistry, be it what you call the natural science, education, or what have you. And I am expecting students will now be getting more interest in what they do because they are modeling something that is realistic in whatever the topic they teach them. Then it comes to engaging scientific writing. The three key responsibility of every university is to teach, is to conduct research, and to do community service. And one of the key ingredients that distinguishes a scholar from one another is scientific contribution. I am sure I'm here today not because I come from Ghana, because Indonesia has over almost 28 million, population, almost 28 million from the literature I checked. But I'm here because I am possibly doing a lot of research which is catching the eye of the global community, and for the past 5 years I have been ranked among the 2 best percent scientists in the domain of mathematics, and that for me is an impetus which will serve as a catalyst to be invited to engage in other colleagues so that we can co-share knowledge, and to better also add We also expect that we have a lot of engagement beyond myself as a mathematician, also to go back to Ghana and share this experience with other faculty members in different disciplines like biology, physics, chemistry, almost every domain in this faculty, so that they can also collaborate, which will move towards the expansion of frontier of knowledge, which will bring innovation in society.
Okay, so like you have like bring here from Ghana and from your experience, like you wanna like develop the models for the lectures here and for the student, yeah, like you wanna share your experience from your past life, and also like you wanna give them like engagement. So like for all the student, like you can make models from your like subjects or your knowledge, because like models is not like just like that, but
yeah, it's not about math. We can model in anything. So because we are modeling in mathematical, we can have physics modeling. We can have modeling in biology, modeling in biological process, modeling in life and other life science, modeling in data science processes. I mean, we can model anything.
yeah, because it's more like combination, right?
Yeah.
Oke. Jadi teman-teman, dari pengalamannya Prof Ebenezer ini, beliau emang sudah banyak experience-nya gitu ya, dan beliau tuh kesini untuk mengajak teman-teman semua, para mahasiswa dan juga dosen untuk apa ya, lebih mendevelop gitu ya, dan lebih engage dengan model gitu ya, model matematika. Karena sekali lagi matematika itu nggak bisa berdiri sendiri sebenarnya. Kita juga butuh subjek-subjek gitu ya, dari biologi, dari fisik, dari kimia, seperti itu, untuk kita kembangkan lebih lanjut lagi. Okay, for the next question, specifically for the workshop on proposal development and scientific writing, what are the most common challenges that researchers face nowadays, and how will your workshop help them overcome those challenges?
Research, it is an art of skills which you have to develop. You could be a very good academic person, but you may not be a very good researcher. And one of the things researchers normally don't look at is identification of a gap. And I did say yesterday during my talk that if a study is conducted, let's say Western Java, then you take the same instrument and come and implement Western Java. What gap for me are you going to fill? It's just, don't forget, a country's character is almost the same. You use the same currency. The food you eat here may not be too different from what they eat in the Western Java, and so on and so forth. So that may not be too much of interest. But a gap that mostly contribute to maybe methodology of how certain things are done, or contribute to theory development, or maybe a certain conceptual framework, improving existing concepts that are existing. That's for me worth fulfilling. That is one problem. Then another problem, how to write problem statement.
Okay.
A lot of researchers think that writing page upon page is the problem statement. No. A problem statement must have a characteristic one. What is the current state of affair? For example, if you say that students do not do well in life sciences, fine. That is the current state, we agree. The next thing, what is your evidence? So you must provide evidence which should be empirically viable. If your evidence is just based on your experience, what your experience is relative. Yeah. Your experience on something may be different from the same. Somebody say this water tastes very good. Somebody say this water no. Are you getting the principle? So now once you provide the evidence, the next thing you have to do is to sometimes provide what you call an intervention. So the intervention means So what are you going to intervene so that the problem that you have claimed to have identified will be solved? So in your life statement or problem statement, you should tell us how are you going to solve the problem that you have identified. And in some cases, before you identify how are you going to, solve the problem, now you go back to literature. The problem have you identify. There may be a gap. It may be due to methodology. That is why that problem is happening. It may be due to maybe the way teachers teach. It may be due to maybe the people over there, their orientation, their cultural orientation, and so on. So you must now align with literature. So literature gap must be occasion the research problem. In other words, they must sit where synchronized. Then finally you have to provide the intervention that you are going to give so that the gap can be filled. And most people mix this ingredient in the statement of problem, which donor funders look at it carefully. And don't forget, statement of the problem is the engine of the entire project or the research. I call it the car engine. I call it the fuel in the car. So one that is not well established, everything you do is just much to do about nothing.
Okay.
Yeah.
So like there's a lot of things that comes when it comes to research, like from the theory, and then the how to make the right problem cases. Because like you said before, every person have their own side. Like maybe from that water, from the first person is not like, I think it's good, but for the second person is not that good actually. So like there's a lot of variables.
So let me add also this, that a research like is normally proposal and whatever it is, like a flow chart.
Yeah.
Okay. So you identify a problem. The problem must be solved through questions. So the research objectives must be derived directly from it, the research problem. So if I read objectives, it must be targeting the issues identified in the research problem. But I cannot use the objectives to collect data because there should be questions. So I transform or I modify or I might convert the research objective into what? Research questions. Don't forget, research objective and research question, they must have the same meaning. So you have my research question 1 and research objective 1. The meaning might be what? The same, except the one is a question, one is what? Objective. So then you must also look at what you're doing with a certain existing theory or theories, what you call theoretical framework. So it is the lens that you wear, which you can see your problem in the realm of what? Certain existing theory. For example, if your problem deal with teaching and learning, maybe difficulty in teaching or difficulty in learning in classroom, then if I wear some learning theory, can I see my problem in that lens? That is what should guide the work. Then these objectives that I've identified the research question, the operational keywords must be, that we call what? The concept. Because these concepts are found in these objectives and then these research questions. These are the things that are used in reference to the theoretical framework to produce what we call the conceptual framework. So if I read your conceptual framework, it must align directly with your research what? Objective. Because that is why I'm going to have your independent variable, moderating variable, and so on and so forth, which must sync well in your research questions. Then you go to the methodology. The methodology, one of the key things most researchers forget about, the difference between research philosophy and then research paradigm. If philosophy are just beliefs people hold about research. For example, somebody who believe about called positivism, which believe that they hold what you call a single view about a phenomenon. If this is water, you see it's a water, you also see it's a water, and so on and so forth. Which the way they arrive through knowledge is quantification, quantity, maybe experimentation, and so on and so forth. And then the axiology is also based on what you call there's a little bias, because it is follow pure scientific principles. And we have post-positivism, which is a bit relaxed compared. Then we talk about interpretivism, constructivism, where we have multiple realities, and so on and so forth. So if we identify a problem, same problem, this madam here will ask, what is the color of this water?
Yeah.
So look at very deep white, some kind of light white. So everybody sees one problem in different angle. That's the multiple what reality. So bringing each individual reality to make a decision, that's we're talking about in interpretivist paradigm, for example, right? And therefore, the way we arrive knowledge, what you call epistemology. Then you view maybe through interview, through open questions for you to answer. In other words, engagement that require your view, observation, and so on and so forth. So you read somebody research questions, definitely you must align with the belief the person has. That is why same problem, 2 or 3 people can look at the problem in different lenses. And that also leads you to the approach, which basically 3 approaches: quantitative, qualitative, and mixed method. And within this, we have different designs. Like the dresses they wear, maybe the basic, if you wear this, you call maybe top and down. But the top and down may have different design. Somebody may have a short, tall, short hands, and so on and so forth. So the approaches have different. So you must understand all these basic principles. Otherwise, your paper will be flat. Quality general will not, accept.
Oke. Berarti kita juga selama kita melakukan research gitu ya, kita nggak bisa hanya maunya kita tuh apa gitu ya, kita juga harus bisa ngelihat ke real life-nya tuh seperti apa gitu, karena pasti kita ngambil data gitu ya, pasti research-nya itu ya, sekali lagi pasti setiap orang itu kan punya sisinya masing-masing, punya jawabannya masing-masing. Itu bisa kita pandang sebagai tantangan, tapi itu juga sebuah keunikannya gitu ya, dimana sebuah multidimensional itu yang bisa kita kembangkan lagi untuk menghasilkan research yang lebih upgrade lagi gitu ya. Oke, Prof. Speaking of internationalization, you are also doing a collaboration initiation during this visit. How do you see the potential of future partnership between your university in Ghana, AAMUSTED, and UNESA? What kind of joint project can we look forward to?
Thank you. Currently, I'm looking at situation where we could have maybe 1 or 2 postgraduate students coming here to do maybe their masters or Ph.D. So I'm going to talk to the international office and see. I'm also looking at the possibility maybe a faculty or student coming to Ghana to stay shortly and learn what we do over there. And because university ranking to also one of the ingredients in internationalization. And that is why it is good to have partnership. Also looking at a situation where maybe it is possible for faculty to do what you call urgent visit For example, in December, I was in Institute of Kinmongi Technical Institute at in Thailand. I spent 3 weeks as visiting professor, then work with professor I visited and her Ph.D. candidate in her lab for 3 weeks. And I've also visited other countries for similar activities. That is what I'm looking for. Like I said, there's a memorandum of understanding between my university and UNESA already, which is possible, or which is one of the reasons why I was able to come here, because there's a relationship. One, that relationship has been established. What is important? How do we scale it up so that there will be more activities? And one of the things yesterday I discussed with one professor here is about trying to bring in 1 or 2 people from Ghana. And I'm sure the faculty doesn't have any African student around. Maybe this visit will lead to that particular project, which would be good. Thank you.
Okay, so the key is scale up ya. Oke, so jadi teman-teman dari project-project dan juga kunjungan Prof ke sini itu kita juga bisa dapat nih banyak keuntungannya gitu ya. Misalkan tadi kita bisa jadi bertukar research, terus juga di kedepannya mungkin teman-teman UNESA ya, FMIPA UNESA ini bisa kayak pertukaran pelajar ya, study exchange gitu ya ke Ghana seperti itu ya. Dan juga pastinya dengan adanya kunjungan ini kita juga bisa bertukar perspektif, bisa juga menambah wawasan kita juga, dimana mungkin dari informasi-informasi yang Prof bawakan ke sini bisa jadi ide research teman-teman gitu ya. Oke, so dari dengerin tadi nih aku Prof ngejelasin, aku makin yakin kalau FMIPA ini bisa makin global gitu ya. Mungkin start dari from Ghana, mungkin nanti next ada kunjungan-kunjungan dari lebih banyak profesor-profesor hebat dari berbagai negara, sehingga kita bisa scale up skill kita gitu ya dan pengetahuan kita. Okay, Prof Ebenezer, many young students are still afraid of mathematics or find it intimidating. As a top professor in this field, what is your message to our students at UNESA to motivate them to love mathematics and science?
Thank you. And not only UNESA students fear mathematics, in US, everywhere that I've visited, students fear math. And I think one of the reasons has to do with the way we teach mathematics, in especially at the pre-tertiary, the primary, the junior high level, and the secondary school. And one of the problems that research has also shown that in some cases, teachers teaching mathematics themselves did not understand the basic concept well. And therefore, what most teachers do, what we call procedural way of learning. So, for example, a teacher teaches a learner how to solve quadratic equation. And the teacher says that there's what we call a formula, quadratic formula. So if you give a quadratic equation, maybe 2x squared, because the x squared is attached to this, wherever you see this, put the 2 there in that context. Or maybe basic example, indices. Then the teacher says that in indices, if you multiply an index by another index, let's say 2 exponent 2 times 2 exponent 3, then the teacher says that when the base are equal, the base are the number down, they are equal. Then when they are equal, all that you need is write one of the base, so 2. Then the top that have been raised, one is raised to 2, one is raised to 3, just add them. But the question is why? The teacher cannot answer in most cases. So let's learn this mathematics just based on what? Procedures in solving. But why are they doing that in that way? Sometimes the teacher themselves cannot. So mathematics must rather be taught based on conceptual what? Understanding. How would that happen? Engage learners with the right activities. We talk about modeling. problem-solving based learning, so that learner learning 2 raised exponent 2 knows that we are repeating 2 3 times itself. The teacher knows that, the learner knows that 2 exponent, let's say 4, 2 is being repeated itself by 4 times. And therefore, if the learner is supposed to multiply them, he can just even count. That is the proper base of learning math. Than to tell the learner that when the base are equal, just add the exponent. So when the base are not equal, what happens? Then the learner cannot do. Let me also give you another simple scenario. In geometry, we teach learners some basic geometric formula. In geometry, so the area of rectangle is half base times what? Height. But you know, this table there where we are conducting, if I have a saw and cut this table diagonally, I'm going to have 2 triangles. Do you know that? If you cut this diagonal, you have 2 triangles, right? So the learner already knows that one of the area of this triangle is half base times height. So if you have not taught the learner area of rectangle, then you ask the child, okay, now you have 2 triangles. This is half base, you have this. So if you put this together, what shape do we have? You say, okay, rectangle. So now put the area here, the area here. Then the learner can do this. That's what we call relational learning. And knows that the area of this we call half base plus half base will give you half plus half is 1. That is why area of rectangle is length times 1 breadth. And that is what we are not doing in school. We have what we call concept mapping. That the idea about something that learners know being transformed to an environment that the learner does not know, but it can be easily applied. So if learners have very good concept mapping, they can do very well in problem solving. And remember, modeling is one layer of problem solving. So modeling is a subset of what problem solving. And most of the way we do math, learners are not being allowed to solve problems, and therefore they find it difficult because there's a distinction between the abstract aspect of math and what math actually should be. And so that's for me the reason why learners are doing well. And once teachers or lecturers begin to employ the new techniques, which is problem-based learning and vis-a-vis modeling techniques, I'm sure learners will enjoy math. Because sometimes you go to class, learner can ask you, say, or Prof, what you're teaching, where will I use it? So the usage itself is a motivation. Because if you are teaching me something, it have no use in my life, why should I be motivated to learn? And that is why and most students are struggling to do math.
I see. Right. So like we should more focus on like the reason of why we learn that
Very
subject,
good.
right?
Especially in pedagogy, when you are teaching, one of the best way of introducing lesson to class is to tell them why they are learning that. Because if you give me this water to drink, maybe it's my first time, I haven't drank this water, I'll ask you why this. So when you drink, maybe to cure this, and then I know I'm taking this water, I'm going to cure something. And I know when you're teaching, I have to pay attention because I know what I'm going to benefit from it. But in most cases, when we are teaching, we don't even tell them what we are going to gain out of the lecture. So like every day we come and sit and go. So you see students sitting in the class as you teach, they will manipulate their phone. You can't do anything. They are adult because they don't see any benefit of what you are doing.
Oke, jadi buat teman-teman FMIPA gitu ya, mungkin yang masih struggle dengan matematik, nanti kalau sedang belajar sama dosen jangan ragu-ragu gitu buat tanya-tanya kenapa sih rumusnya seperti itu, apa sih backgroundnya dari rumus-rumusnya, dapatnya dari mana, dan bagaimana sih kita implementasiin dari rumus-rumus ini ke dunia nyatanya teman-teman gitu. Jadi kita semua juga bisa termotivasi untuk belajar bahwasanya emang yang kita pelajarin itu emang bener loh ada nyata di dunia kita gitu loh, bukan hanya sebatas rumus di atas kertas gitu ya. Oke. maybe that was the last question. Thank you so much, Prof. Ebenezer. That was deeply inspiring. It is true honor to have you here at FMIPA UNESA and on our podcast. Please enjoy your rest of your week here in Surabaya. Oke, Sobat MIPA, bincang-bincang yang sangat membuka cakrawala tentunya gitu ya. Jadi jangan sia-siakan kesempatan emas ini. Ingat seluruh rangkaian VTP tahun ini tuh diadakan di Auditorium Slamet Dajono Gedung D1 lantai 3 FMIPA UNESA. Dan ini free of charge alias gratis gitu ya. Yuk langsung scan QR code-nya atau melakukan dari link pendaftaran yang ada di brosur-brosur atau sosial medianya yang bisa teman-teman cari di FMIPA UNESA gitu ya. Sebelum kita akhiri, aku mau pantun lagi. Buruh cendrawasih terbang ke utara, hinggap sebentar di pohon kelapa. Terima kasih Prof. Ebenezer atas ilmunya. Semoga sukses membawa FMIPA mendunia. Jangan lupa ikuti terus update kegiatan VTP di media sosial resmi FMIPA UNESA. Sampai jumpa di episode mikrofon berikutnya. FMIPA, kampus konservasi, tangguh, berprestasi. Jos, jos, jos. Wassalamualaikum warahmatullahi wabarakatuh.